Alright, so here we're going to answer a couple homework questions from Chapter 6. X is normally distributed a random variable with a mean of 5. If the probability that X is less than 6.54 is 0.67, as shown below, then what is the standard deviation of X? Alright, so let's make a diagram because I didn't have one provided to me. I know it's normally distributed, so it's going to be bell-shaped. I know in the middle, I'm going to have mu equal to the mean, which is 5. Alright, they tell me that X has a probability of 67%. They also told me that X is less than 6.54. So I'm going to put a line here at 6.54, and that's what my X equals. And the probability is, as always, my shaded region underneath the curve. So they're asking specifically for what is the standard deviation of X. So you got to think about this for a second. We have a couple things that relate to these variables. One of them is the formula X minus mu over sigma is equal to your z value. Furthermore, we know that the z value is equal to the area, it's equal to inverse norm, the area under the curve, 0.67. So with that, we have two equations, and we have all the little bitty pieces except for the sigma. So let's go ahead and plug those in and get what we need to get. So we know that X is equal to 6.54. We know that mu is equal to 5. We don't know the sigma, so it's just going to be sigma. There we go. And the z is going to equal our inverse norm of 0.67. So I'm going to go over to my calculator and do a little bit of algebra on this. So what I want to get is, I know sigma will equal 6.54 minus 5 in parentheses divided by my inverse norm of 0.67. Wow, that's really bad. Okay, sorry, it's not centered very well. So now I'm just going to go ahead and plug that into my calculator. So I'm going to open up parentheses, 6.54 minus 5, close parentheses, divide by second vars, which predicts my distributions. I go down to inverse norm, 0.67, close parentheses, hit enter, and I'm just going to go ahead and drop all that other stuff. I now know that my sigma is equal to 3.5. And there we go.